Hi, in this video, we are going to look at the different components of 5G and how it is going to help to build smart ports. 5G. What is 5G? Why 5G? What about its applications? What are its advantages and disadvantages? What are the challenges of 5G? And how can 5G help to build smart ports? Without further delay, let's get started. A quick review of the previous generations of wireless networking. The first generation had only basic voice service and analog-based protocols with a speed of 2.4 kilobytes per second. The second generation, designed for voice and SMS text messages, with improved coverage and capacity compared to the first generation. Its average speed was about 64 kilobytes per second. Moving on to the third generation, designed for voice with some data considerations such as multimedia, text, and internet with a speed of 2 megabytes per second. 4G, which is an improved version of 3G, was designed primarily for data with a speed of about 100 megabytes per second. What is 5G? 5G stands for the fifth generation of wireless networks, and its goals are to increase data speed, approximately about 1 gigabyte per second, set up a more reliable connection for devices. Why 5G? 5G is not solely about making bandwidth larger or speeds faster. 5G will play a role in emerging Internet of Things applications and can be used for many diverse applications with different speed, response time, security, and capacity requirements because it can support up to 1 million devices per square kilometer. 5G will enable more technical benefits, that is, network slicing will help reduce pollution, improve port traffic management, and guarantee an adequate communication in cases of emergency where rescue teams can be contacted.
Here are some advantages of 5G. Increased bandwidth for all users. For those who don't know, bandwidth is the connection speed available for people who are using data to download files, view internet pages, and watch videos. The less bandwidth that is available, the slower everyone's devices will run. With increased bandwidth, faster speed will be achieved. Data transfer speed are projected to be about 10 times higher with 5G than is possible with 4G. That means significantly faster transmission of images and videos. With 4G LTE, downloading a high-definition movie might take about 10 minutes. With 5G, it should take less than a second. Another benefit of 5G will be shorter delays. Though it's not always noticeable, there is often a brief lag in time from when data is sent to when it's received. 5G should reduce this so-called latency, making it possible, for example, to watch high-speed virtual reality videos with no delays or glitches. Another advantage is increased connectivity. Cell towers equipped with 5G technology would have greatly increased capacity over 4G LTE. That means more people and more devices should be able to communicate at the same time. Here are some disadvantages of 5G. An increased bandwidth also means less coverage. One of the key advantages of 3G cell towers was that they could cover immense territory with relatively few cells. This is because the network did not require as much bandwidth, meaning networks had to deploy fewer cells. When technology progressed to 4G networks, the cells were producing more bandwidth, meaning the coverage radius of each cell was smaller. As the 5G network gets rolled out, coverage may drop more often than on 4G networks. More cell towers will be required to produce this immense bandwidth because the cells are not able to cover as much space. As more advanced cells will be required, many of the old devices would not be competent to 5G. Hence, all of them need to be replaced with new ones, which is an expensive deal. Security and privacy issues concerning 5G are yet to be solved. And also, developing infrastructures involving 5G needs a lot of funding.
Now let's talk about some applications of 5G. 5G can be used to improve Internet of Things. As we all know, Internet of Things is becoming more and more popular. IoT will connect all applications, devices, and sensors to the Internet, meaning that its applications will collect large amount of data and information from all the devices and applications. Therefore, IoT will require an efficient network for data collection, processing, transmission, and real-time analytics. Thus, 5G turns out to be an efficient candidate in order for IoT to work properly. Next is that 5G can be used in industrial environments. Another application of 5G is in production communication networks. This is not the global production network of factories, but rather it is the communication network inside a factory that allows electronic devices to communicate. For example, to coordinate the operation of machines, read their files and statistics, and install software updates. To do these types of operations, the network needs to be fast enough and also reliable. Moving on is 5G can help in developing self-driving cars. The fifth generation of wireless networks will help making self-driving cars and vehicle-to-vehicle communication a reality. Self-driving cars being connected to the internet will be able to gather information from their surroundings and make informed decisions. Vehicle-to-vehicle communication is the exchange of information at a very fast rate between cars such as their location, speed, acceleration, and direction. Therefore, with 5G there will be less human errors and this will reduce accident rate. Some other applications of 5G include entertainment and multimedia, wearable devices with artificial intelligence technology, improved VoIP for business, and finally, drones with the ability to use 5G network can be useful in emergency cases.
Just like any other new technology, 5G comes with its own challenges. Firstly, with the implementation of 5G, we will undergo a rapid increase of frequency bands. This increase in frequency bands means that our devices must be designed to operate in multiple bands so that they can be transported all over the world and still function seamlessly the way they were meant to be. This requires more complex and more intricate designing of our daily devices such as laptops, phones, tablets, and such. Secondly, the level of integration needed to get 5G to work properly is going to require the elimination of cables and connectors for making calibrated measurements on the integrated systems. Making calibrated measurements over the air, or otherwise known as OTA, is very expensive, very time consuming, and requires a tremendous amount of expertise. Thirdly, we will need to maintain two uplinks. One uplink with the current existing 4G or LTE system, and a new uplink for the 5G system. And these two uplinks will need to be maintained until the full transition to 5G is made. This will require a lot of testing to ensure that the two systems do not interrupt each other and still manage to function properly and provide no inconvenience to anyone.
Now we're going to talk about the application and benefit of 5G in smart port. As cities get smarter, they are becoming more livable and more responsive, and today we are seeing only a preview of what 5G technology could eventually do in the urban life. Until recently, city leaders thought of smart technologies act independently from traditional industry, primarily as tools. However, now technology is being injected more directly into city, making these technologies as part of the city rather than tools. This will be further enhanced with the application of 5G in smart ports. 5G will provide SmartPort a vertical optimized platform, catering the various requirements in an efficient way. The industry demands for 5G requires a complete transformation of the network system and creates a need for a new network architecture from the ground up. This new network architecture is called network slicing. Network slicing lets service providers partition our networks into discrete horizontal slices to support specific use cases in vertical segments such as in energy, healthcare, and manufacturing. Network slicing is a specific form of architecture that allows multiple logical networks to run on top of a shared physical network infrastructure. When utilizing network slicing, users in SmartPort have access to highly customized networks tailored to their specific requirements. Let's take an automotive industry for example. The automotive industry have smart car that requires an extremely versatile network so that they can simultaneously deliver for autonomous driving and device-to-device communication. This diverse requirement will be served from the mobile broadband provider in the form of automotive slice. While 5G is still at its infancy, there have already been real-life applications of these technologies in cities around the world. One example can be seen is in China. In 2018, a Chinese telecom company announced they are developing a 5G SmartPort system at the port of Qingdao in China. The companies predicted a decrease in 70% of labor costs with the 5G automation upgrade. Besides that, they achieved an automated ship-to-shore crane lift of a container over a 5G connection operated from a control center. The 5G connection included data traffic from more than 30 HD cameras as well as control data for a PLC controller. This operation requires very short latency control signal as well as stable remote and real-time control requirements which only 5G technologies can deliver. Another example of 5G implementation is in Germany. In 2018, a German telecom company announced they have tested 5G for several different applications. The focus of their new project was on a new technology concept called network slicing, as previously mentioned in earlier this video. One example of this technology being used is a rapidly instantiated priority circuit for emergency services in a port area during a storm surge. Another one is sensors were installed on ships and enable a real-time monitoring and analysis of motion data from large parts of the port area. Besides that, J also remotely controlled the traffic flow in the port of Hamburg via a traffic light connected to the mobile network. This should help to guide trucks faster and more safely through the port's area. Now what this project proves is that complex industrial applications with different requirements can reliably work over a common physical infrastructure. So one of the benefits of 5G is it is able to enhance maintenance experience. With 5G, network slicing is being used. The engineering team of the SmartPort are able to implement virtual reality and augmented reality application for daily work with ease. The AR/VR equipment is connected to a centralized server through the 5G network using a dedicated network slice. The engineering team can have easy mobile access to construction plans and technical installations. Moreover, using 5G can enable live streaming of computer-aided design and simulation of data. Smart glasses can also be used for the workers to use 3D imaging. This use of 5G can greatly enhance maintenance experience on the smart ports. Another benefit is it improves port traffic management. The traffic lights are connected to a port central traffic control management through 5G Intelligent Transport System, also known as ITS. The traffic lights are connected to the port central road traffic control management through the 5G mobile network with a dedicated network slice. This implementation can help SmartPort manage traffic better. Another benefit of 5G in SmartPort is it is automated. With 5G available, SmartPort technology can be automated for use in SmartPort. With 5G having high transfer data rate, there is less latency and there is no lag time in the network. Autonomous truck and operating machine can be used, thus leading to less use of human workforce in the SmartPort. This leads to the way to a digitalized SmartPort for the future.
We reached the end of our video. Thank you for watching and please leave your comments.